Hi, everybody. Good morning. This is front-end architecture for scalable design systems, or as I like to put it, how the heck do you build a design system, a modern, scalable design system that's maintainable, that's flexible, that's easy to integrate, and that's framework agnostic in 50 minutes or less? Just a really quick thing to point out. Slides are posted if anyone would like to grab a copy and follow along today. And I know I'm going to cover a ton of material, so if there's any questions that you guys might have that we're not able to cover today, please tweet me questions and I'll get back to you. So, if anyone doesn't know me, I'm Salem Ghoweri. I'm lead front-end architect at Pegasystems here in Cambridge. I've been a front-end developer for the past 7+ years, and I've been focusing almost entirely on building out design systems and a couple pattern libraries along the way for the past 4+ years. I'm also one of the core maintainers of Pattern Lab, open source project. It's really awesome. You guys should totally check it out if you've never seen Pattern Lab before. And I've been doing all this stuff really under the umbrella of working on the Bolt design system, which is my day-to-day job at Pega. So Bolt is our open source Pattern Lab web component powered design system that powers all of our web properties, our Drupal sites. We'll be chatting quite a bit more about that, but just FYI, that's a lot of the context what we're going to be chatting about today. The thing is, though, we didn't start with Bolt. Bolt is actually the direct result of a lot of the learnings over the past 3 years trying to get a design system stood off the ground. 3 years ago, when I first started at Pega, things were quite a mess. We had every button under the sun. We had no consistency, no reusable templates. It was all over the place. So we did what any up-and-coming front-end team would do, and we used tools like Pattern Lab to build out our very first design system. We also used all of the latest and greatest best practices in the front-end world. Things like ItCSS, the inverted triangle CSS methodology by Harry Roberts. We used Sass, we had BEM, we used Webpack, we had Twig templates, we used Gulp for our build process, we used atomic design. The things that you do when you want to build a design system and do it the right way. We also looked into the industry. We looked at all the DrupalCon presentations at the time, and we really wanted to make sure that we were incorporating the best of class Drupal plus Pattern Lab integration best practices. Things like building our templates to use Twig that's friendly with Drupal and lived directly in Pattern Lab to make sure that we're not just pretending like these components are going to work in Drupal. We actually have an environment to build and check that these in fact will work in Drupal. We did what you're supposed to do. We documented our components with Markdown. We had our demos and our examples in Pattern Lab. We had Twig namespaces and used the Drupal components module to make sure that we had that really tight Drupal Pattern Lab integration that all the DrupalCon talks talked about. We also did, at the time, what was considered to be bleeding edge, and we actually took our design system's Codebase and we separated it out into its own separate Git repository that was then pulled back into Drupal via Composer. Brian Perry actually just talked about this concept at DrupalCon this year. So we did all these things, and people used it. We actually were able to get a lot of our internal Drupal sites powered by this very first design system. And it was perfect. The end. Any questions? Actually, even though we did everything that every other conference out there, every other blog post, every other tutorial said, do these things and you'll have success. Even though we did those things, our very first design system started having some serious problems. Scalability problems. We had poor documentation. We had questions like, how the heck do I use this component? What are the different options? Or where should I go in order to find out what the most recent releases of the design system? We had issues and questions about how we actually shipped our design system. We had problems like, hey, I want to go pull in just this one component. How do I do that? Or, I just want to pull in the design system's code, but I don't want to pull in Pattern Lab. That's not the design system. That's the tools you guys use. How come I'm installing that when I try to pull in everything? We had major issues with component fragmentation. For example, we had a lot of hard-coded issues. Things like workarounds that were implemented in Drupal that no one told us about. And then we go to push out an update and it inadvertently broke something. Or issues regarding workarounds that basically undermine a lot of the templating and a lot of the systemization the design system is supposed to support. And we also had issues with the actual integrations themselves. Issues regarding Twig extensions. Issues regarding, honestly, just general maintenance and cleanup in our code base. So for example, because we were using the Drupal components module, even though we're only making a change in Pattern Lab, so say we're renaming a template folder just to make sure things are more consistent internally. Because that actual path changed, it would inadvertently break any of those hard-coded integrations in Drupal, and we have no idea. The fragmentation issue that we're seeing actually got so bad that at some point, we were asked to make half the pages on one particular Drupal site use the old version of the design system, and then the other half have to get upgraded to the latest version of the design system, over a year's worth of work. And by that point, we knew that our first design system was effectively dead. So the thing that we really had to think about and figure out going through this whole ordeal was, what does it mean to be scalable in the context of a design system? And in my opinion, it's actually two things. First, your design system needs to be maintainable. Once you build something, how do you maintain it, support it, and improve it over time? And that's a lot of the infrastructure stuff like, and workflow stuff, like coming up with bug fixes, having component documentation, incorporating testing coverage, how do you handle refactoring and enhancements over time, those sorts of things. There's also the fragmentation issue. So maintainability really is like an internal concern. How do you make sure that code base that you're producing, you can kind of keep it all together? Fragmentation is once we've produced something and we've published it, we've shipped it out into the wild, how do you go from that thing being a one-off to being something that is maintained, supported, upgradable, hard to break? That was really the hardest part, because all the other systems out there, all the other guides and references that we were using, they didn't really have an answer to this problem. It was really like, hey, you've shipped your design system, great, job's done, mission accomplished.
I can't get the answer to Thanks, Siri.
Even Siri knows that.
Siri doesn't know the answer to that. So we rebuilt. And we rebuilt to create Bolt. So the Bolt design system was created specifically to address all of the pain points and problems and catastrophic issues that we encountered over the first year and a half going through this design system journey. We wanted to make sure that we had more maintainable documentation and that our demos were actually kept up to date and kept to be relevant. We wanted to make sure that we had more flexible, more encapsulated, and cross-platform friendly components. How many times do we have to implement the same button before we can come up with the one button that everybody can use and customize and everyone's happy with? We also wanted to make sure that we cracked this really, in the Drupal space at least, this really hard problem of, I don't want to have to install everything in your design system's code base. If I want to pull in just the button, just the card, just the carousel, I should be able to do that and not have to get everything installed as a result. And finally, we wanted to make sure that the integrations, these super fragile, one Twig template rename or one folder change away from breaking everything, we wanted to make sure that integration process between the design system's single source of truth and Drupal was as automated as humanly possible. So one way that we were able to do this was through API-powered documentation. And I know that sounds kind of crazy, but hear me out. So the first step of this process was making sure that we wrote code that was structured. So for example, instead of having our color palette in Sass written out as just bespoke, totally unrelated Sass variables, we're using this feature in Sass called Sass Maps, which is basically a collection of that data all in one spot. So for this example, we have our brand color palette in one Sass map. Next step is we export that data. So now that we have our entire kind of group collection of data, we have tools that take that data and put it in a place where other systems can actually integrate it and pull it in. So for this example, we take our Sass code, and then we output it as JSON data automatically. Step 3, teach other systems about your design system. So don't worry too much about the actual code here. This is just an example of what we did with Twig integration, but really the core idea here is your design system cannot be just these bespoke processes or bespoke little microservices that have no idea how to talk to the rest of your system. You need to teach the Twig layer, the PHP layer, the Sass layer, the JavaScript layer. You need to teach all of these things in your design system to talk to one another, to be able to share that single source of truth at the data layer, so that we can do things like this. We can have a color palette that is always up to date, never obsolete. It always reflects whatever the colors actually are, automatically. So for this, we are looping through all of our color palette data, passing it along to our color swatch template, and then rendering our always up-to-date color palette. You can also do some really cool things too, like this. This is actually an automatic accessibility check for all of our color palette options. It's checking to see if, given this particular color and this particular text size, small, large, light text, and dark text, it automatically is checking to see what passes our accessibility guidelines and what fails. Again, automated. No one has to maintain this, it just works. Next up, let's talk about component schemas. So who here knows what schemas are? Well, I didn't know what schemas were when I first started this crazy journey. The way to think about schemas is it's the codified source of truth that describes how stuff works. And the way schemas are written is in a way that makes sense to people when you're looking at it, but also to machines. So it's documentation, but it's documentation that people and processes can use to do some really awesome stuff. Things like automatically checking the data is valid, or making sure that you enforce certain rules of the data that you can pass along to a component. So for example, if the button component had primary, secondary, and tertiary options, you can't pass in the blue button option. Doesn't exist. You can also incorporate defaults. So say you forgot to pass in your button color, it's not primary, secondary, or tertiary, you just didn't pass anything in at all. Schemas can allow you to set defaults for that behavior so that as an end user, a content author, a developer, they can pass in as minimal information as possible, and you still can incorporate consistency across your design system. The way that we incorporated this was, and it's crazy, first we just started writing some schemas. Just going through all of our components in the system and saying, hey, this is the button, it accepts text, it accepts color, it accepts a URL, etc. After going through that process for all of our components, we wanted to make sure that we didn't negatively affect, say, our build times, our build process times, both for our team internally, but also for Drupal developers pulling all this in externally. So we actually ended up aggregating all of the data, all of the schema data in the design system into one place. So rather than having every schema just kind of living on its own, we have one master data feed that has every component with every component schema all in one spot. This should seem familiar because it's also very similar to what we talked about in the last section with the API-driven documentation. We want to make sure that we're teaching all of the systems in the design system, things like our JavaScript, our Twig templates, how to use the schema data to provide value to developers, designers, and content authors. So globally, make sure that data is available, make sure that we can validate the data that's getting passed along, and automatically setting defaults. And like I just mentioned, this isn't just a Twig-specific thing. This is also applies to JavaScript. It applies to really any paradigm or any tech stack in your design system that needs to have the same consistent overall behavior, even if the plumbing needs to be a little bit different. And then we use this to power practically everything in our design system. So for this example, we use schemas to actually automatically generate many of our demos that we have in Pattern Lab. So this example here, for every size option that we have in our button, go run through it, put that size in the text, and generate the demo. You add a new size to our button, this is up to date. You remove a size, this is up to date. We don't have to worry about every one of our demos breaking every time we make a change. Practically speaking, we also use this for generating our component documentation. So this is an actual screenshot of our schema table right inside of Pattern Lab. Pattern Lab doesn't know about this. This is content that we have. So this is really just visualizing in a people-friendly way. Here are the different options available for this component. Here's a description of it. What kind of data is it? Is it a Boolean? Is it a string? Is it a collection of data? So is it like an array or is it an object, etc.? Are there defaults? And then for certain types of schema options, you might have, say, a list of options. You need to pick an option, text alignment. Is it left aligned, center aligned, or right aligned, etc. You can also do some really cool things, like this. We actually use our schemas to power a lot of our automated testing that we have. So I could do a whole other section of just about testing, but it's not enough time today. Needless to say, the same technique that we're doing in Pattern Lab with our demos, we can also use that same technique to actually loop through the options and automatically run tests based on every one of those options available. And we really need to talk about validation because that's really one of the core benefits of schemas in general. This is an example of command line validation that we can automatically run everything through in the context of Pattern Lab. So, for example, we have the text property in our button being a required property. So that text, it might be visually hidden if it's an icon-only button, but it's still required no matter what context you're using the button. So if you don't pass along text, it barks at you. We can also actually take the same idea behind the schema validation and expose it in the browser, in the console. So this is in the context of Drupal having in-browser component validation. So for every page that you go on, you'd be able to get a top-level view on what components are actually, you don't see the components that are working great, you see the ones that have some issues that need to be taken a look at. And this is one of my favorites. We also have this in-browser component explorer. It's kind of like a playground. This is basically taking all of these different ideas, the idea of having our different schema options. You can map those out to input fields. You can pass it along to an external service to render our templates. Basically, let content authors, designers, developers play around with the thing and have the options that are available always reflect what options are actually available. all completely automated. So you set it up once, and then as we change it, update it, improve it, this will always be up to date. Really, you could think of schemas as like a superpowered type of documentation that can really power anything and everything from validation to testing to setting defaults. You could use it to generate your component documentation. You can generate people-friendly previews of how components might be authored. It does a lot of stuff. It's really awesome. Next up, let's talk about web components, specifically Twig and web component integration. Now, just a quick show of hands, who here knows really from the bottom of their heart what web components are? You get 2. 2.5. Web components are really exciting. They're really, when it comes down to it, they are a collection of low-level APIs in the browser. They are custom elements, which are custom HTML tags. Think of like a video tag or a select tag in the browser. These are custom tags that you define, like bolt button or bolt video, that teaches the browser how to actually render that thing, what options you can pass along to it to configure it. It's really a super declarative way of defining component behavior. You have shadow DOM, which is a way to encapsulate the HTML and styling for that component. So really reinforce the barriers between the outside world and the inside world to make sure your components actually don't break out in production. You have HTML templates, which we actually don't use too much on our end, but they're part of the spec. They're basically a way to easily stamp out reusable templates without a lot of extra performance overhead. And then finally, ES modules, which are basically a way to share your components themselves into other components. So ES modules exist in JavaScript, so you can pull in, say, the button into your card component that you're rendering, and all of that component's JavaScript, HTML, CSS, etc., come along for the ride. Really, web components are the native component model being brought to the web platform. And it's worth mentioning that there's a lot of really great examples and libraries out there to help make these super low-level APIs a heck of a lot easier to get started. So we use lit.html and skate.js. They're really great, really helpful libraries to help make the assembly of these things super easy. But there's more, fully built-out libraries out there that, like Google's Lit Element project, also Stencil.js, which Ionic Framework uses. And then there's also some even higher level frameworks like Polymer 3, Ionic, and believe it or not, a lot of the major JavaScript frameworks out there like Angular, React, Vue.js, they actually fully support web components. React is still getting there, has a couple small kinks to work out, but for all the other ones, Angular and Vue has perfect support, 100%. Now you might be asking yourself, oh, that sounds great, but what's the browser support like? It's actually extremely good at this point. In fact, Chrome, Safari, Firefox, and Opera all 100% support web components, all evergreen browsers. Microsoft Edge, and especially the new Edge, which is going to get 100% support, have about halfway support right now. So you need a couple polyfills to help bridge some of the gaps that are still getting worked on. And even IE11, which we have to support internally, IE11 with some of these polyfills can get the same level of deep browser support like all the other evergreen browsers. Now, just to make sure that this sort of makes sense to everybody, I actually put a really quick example of what this actually looks like if you wanted to implement an actual component to be a web component. So I'm going to just take you guys through this real quick. We have our import statements up at the top. So pull in some helper functions and libraries from other parts of our code base. So we have our bolt base, which is our base HTML class. HTML, which is coming from lit.html, which allows us to really effectively render HTML in our component. We're pulling in our button stubs from button sets. And we have this helper library called class names. It's not required. It really just makes it super easy to make it easy to manage adding and removing class names to your component. So we pull in some stuff. We define some props. So these guys are going to really define what options are going to be available on your component. So in this example, we have URL, size, and color being 3 different properties that you can customize and configure on your web component. Next up, we have the render function, which for anyone who's worked with React or Vue should look super, super familiar. So this is, this is using the class names library to make it easy to say, hey, if you passed in a button color, use that button color option that you passed along. And if you didn't, default to the default for this primary button color. Also, use that to define what the default button size should be. And then finally, last but not least, we render. So this is a simple example. So we only are rendering our button with an anchor tag, but our actual component, such as between a semantic button tag versus an anchor tag, depending on the options. But really, it's write your HTML that you want to render, incorporating those different configuration options, those different props in. And then, because we're using Shadow down here, we actually directly just pass along the SAS code compiled with CSS right into our component. And then finally, this custom elements.define really is what registers this entire component definition with the browser. So you do all that. And then, as long as you're pulling in your JavaScript that has this code getting compiled, you literally just put a bolt-button tag on the page, pass along what URL you want, and you literally get your whole button component rendering. Semantics, accessibility, and all. The really powerful part comes from when you take that exact idea and start incorporating it across multiple platforms. So in other JavaScript components, you can import in, say, your button component and directly use it within the context of another component. In Twig, which Drupal is going to be using under the hood, we directly reference our button.twig file, use the same prop values that our web component is going to be using. And I'll get to it in the next slide, but that actually is going to be rendering our web component unbeknownst to the template they're actually passing along here. Even though you're using it in the context of Twig, the Twig template is actually just putting together the web component markup that you need on the page. And then finally, you can also just use this as a static HTML bolt button tag. So whichever way you need to integrate or whichever context you need to use this component model, it's available. This is also one of the kind of sort of crazy but also really powerful things we've been running with for the past year and a half. We don't just have our button component render in our Twig template. We actually pre-render what that final button component is going to look like in our Twig templates. So what this is basically doing is emulating the final web component rendered markup. Class names, HTML structure, semantics, all of that. In our Twig template that's going to be output by the server. But we're also setting up that static HTML to be easily thrown away as soon as the web component's JavaScript boots up. That way, as soon as the JS kicks in, you get the top right corner version, which is literally just the bolt button tag and the plain text within it. So this gives us really the full life cycle of server-side rendering with client-side hydration without having to create a whole brand new tech stack to support server-side rendering. And also worth mentioning, Shadow DOM. It's super powerful. It gives you your component encapsulation. Turns out it's not actually that fast in IE 11. And we found out that the hard way. So what we came up with was a way to write your component code once, but depending on the context of what the browser supports, where that component is getting rendered. So if you're rendering this component in a form tag, if you're rendering it anywhere else on the page, Or, some components that we use are written using third-party libraries that really don't understand this whole encapsulated markup versus non-encapsulated markup model. So some of our components completely opt out of rendering to this sandboxed, shadow DOM completely. So what we came up with was a way to write a component once, and depending on all of those different factors, what the browser supports, where it's getting rendered, what the component natively supports, it just works. It doesn't matter, the browser doesn't even care about it. The JavaScript itself that's orchestrating all this doesn't have to care about it. You just write one simple component code. Right here, and it just works. It renders exactly what it needs to render, regardless of context. So again, this is a lot of abstraction to make it super simple for other developers to be able to use all the power without getting caught up on some of the details. We actually have a lot of examples in our in the Bolt Design System Codebase up on GitHub of taking this idea of true component interoperability and using it in some really simple examples in other JavaScript frameworks. So this is one using it in Vue.js. We have another one in Angular. And a third one with just plain static HTML. Integrations differ a little bit. So like the Vue.js one has super tight integration. The Angular one has very light integration. And the static HTML one could be any framework, any system, it doesn't really matter. You can integrate it in a whole spectrum of different ways. 2 more sections and we're done. Next up, let's talk about throwing out our entire way of how we publish stuff for forever. Easy stuff. So this is very unholy as far as the traditional way things have been installed and pulled into Drupal. This is using npm Node Package Manager, which front-end developers has been the quintessential way of installing and distributing front-end code on the web for quite some time now. But for the Drupal world of things, it's a totally different paradigm. I'll get to that in a second. But first, we've got to talk about monorepos. So a monorepo is essentially a single source of truth. It's a repository that has all of the different moving parts in your system, the different packages, the different tools, etc., that are all living in one place. Some of the most popular JavaScript libraries and frameworks out there, things like Babel, Gatsby.js, Static Site Generator, Webpack, Vue.js, Storybook, Jest, there's a ton of others. They all use this same model, where there's one Git repository that houses all of the code, and then it distributes out all the individual pieces whenever you're ready to publish out a new release. This idea of a monorepo is actually used in the PHP community as well. Symfony and Laravel, some of the 2 largest frameworks out there for the PHP world, they're actually using the same monorepo idea. So why does all this matter? Well, for starters, it makes for a much more maintainable code base. It gives us the ability to deduplicate and share dependencies across the different parts of our design system's code. It allows us to actually coordinate those updates. So you change, you bump a package version in one place, you can coordinate that package version bump across other components. You swap out a library, you want to get rid of jQuery finally, you can coordinate that across multiple things, keep your code base all in sync. This also makes it a lot easier to maintain and orchestrate your build process, your tooling, your orchestration from deployment, testing, everything. It helps it so much to just have it all be in one spot. From the outside community, it's also the single source of truth for reporting issues, asking questions, announcing your releases. And then, testing. You don't have to just worry about testing components in isolation. You can also orchestrate testing combinations of components all together because they all live in one spot. And then really it's one-stop shop for any sort of changes, small and large, across your whole system. So what this looks like is, from a contribution standpoint, there's one place where all of the code lives. The buttons, the cards, the carousels, the breadcrumbs, everything. It all lives in one single spot. It's unified, it's maintained there. When you're ready to actually cut a release, you publish all of the individual pieces, navbar, table, button group, icon. You publish all of those pieces to NPM. And then from the consumption side of things, from the consumers, the developers, the designers, the content authors that are really going to be benefiting from this whole system, you install and pull in just the parts that you need. So the way we do this is we looked at the industry and said, all right, what's the best tool out there to do the job? And it turns out there's this great tool that's been around for a few years now called Lerna, which basically takes all of the automation and orchestration that you need in order to get this thing up and running, and it makes it super easy. So we take Lerna, we take Yarn, which is Facebook's version of NPM essentially. It's just another command line tool to make it easy to install packages from NPM and other sources. These two together work hand in hand to make turning an existing code base into a monorepo super, super straightforward. And then, as far as like what this actually looks like in the code base, we have our Lerna config, which is really just the tiny version of here's, I want to have a monorepo, here's how I want to actually install and publish stuff, here's the version of our design system's code base. We define where to actually look for those different pieces to version and update whenever you're doing a release. We run a command like Lerna publish, which goes through all of those folders that are getting looked at from the monorepo point of view. And then it publishes all the different pieces to NPM automatically. Now, for anyone who's used Pattern Lab before, we actually had to sort of pivot from the traditional usage of Pattern Lab when we started moving towards this monorepo model. What this meant for us was we started to reorganize our code base so that things don't actually live inside of Pattern Lab. Instead, they're actually just demoed in Pattern Lab. Pattern Lab is being downgraded to just being another consumer of the design system, no different from Drupal or from another third-party integration. Pattern Lab is literally just a window to view your design system's source of truth. It isn't the actual source of truth. So what this gives us is Pattern Lab, the actual code, no longer has to get shipped and installed on Drupal sites, pulling in your design system. And it also allows us to actually test out the integration process, be it in Pattern Lab. We have our own Twig static set generator that we use for some of the other pages of our doc site, Drupal. All of these different systems are now integrated the exact same way through Twig. And from an organization standpoint, this is what it kind of looks like. You have a packages folder where all of the different pieces that are going to get chunked out and published separately, they all live really in one spot. And then everything else, the stuff that supports your design system's code base, things like your documentation site, for example, those just live in another folder. So we call it website. Versioned by the design system, consuming the design system and supporting it. And if anyone's curious, hey, what about PHP dependencies? This all sounds very front-end, JavaScript, HTML, CSS focused. I agree. So what we actually do is we split out any of the PHP exclusive dependencies, things like our shared Twig extensions that Drupal and the design system code both use, and we actually automatically chunk out those folders, put them on separate Git repositories automatically, and those end up on packages, which for the PHP world is where you go to actually install off-the-shelf community contributed code. All that's automatic too. And last but not least, let's talk about integrations, because this entire model is very different from what Drupal would normally expect Twig templates to really come into Drupal. So if you remember from earlier on, one of our core goals was to have a design system that could be installed a la carte, being able to install just the pieces that you actually need. So what this looks like now is you npm install the Bolt button, Bolt build tools, Bolt icon, etc. And this basically is just putting all that code that you need in your node modules folder. Our build tools then take that, you configure it, say, hey, here's where my Sass lives, here's where my JavaScript lives, and you list out actually what specific components you want to use, so you can install the button, but not actually use the button if you so choose. This basically just looks at what code you have and provides Drupal under the hood with all of the different path names to your Twig templates, to your components, so that instead of having to list out manually in your components module theme.yaml file all of the different paths to your templates, we can automate that whole process. And then we have this bulk connect module that we've published, which really just automates that piece. So it's rather than having to worry about Drupal installing the right Twig extensions that are shared and having to write out those Twig namespaces, we just wire that up automatically. So here's what this looks like. We have our package.json file with all the different components listed out, at what versions you want to pull them in and install them. Those get installed to the node modules folder directly within the Drupal theme. And by the way, that works with dependencies of components too. So if you forgot to list out, the bolt button component and it's a dependency of the card, it would get pulled in automatically as well. In Drupal, then we have both our cconfig, which is a super lightweight wrapper on top of Webpack. That just really makes the configuration for your build system as simple as humanly possible. You list out the components you want, you put them in your package.json, npm install, and you enable the bulk connect module in Drupal. And then you just use the components. You don't have to worry about which template this lives in, what the path name is. It just works. So you can, from a design system standpoint, change and reorganize and rename. And from a Drupal consumption standpoint, template integrations are all the same. And we have a full example of this in the Bolt Design System repo. We use a great tool called Drupal Lab. It's essentially a pop-up Drupal site. You can get installed in about 60 seconds or so. You don't even need to really worry about a database. It uses SQLite, so it's super, super easy for anyone to get up and running very quickly. We already have a whole example of this integration up there. If anyone's curious, wants to poke around the code and see really how this integration looks like in person. So we've covered a lot of stuff in a short amount of time. Really, really quick recap. Component schemas are a really powerful way to keep your design system's definitions up to date, validated, and documented. Building templates and components really that are Twig integrated, full-on web components, allows us to really package up more resilient, more flexible, and more interoperable components for use in Drupal and in other platforms and frameworks. By progressively decoupling your design system's code base from Drupal and from Pattern Lab, so this is monorepo-centric organization and distribution, it allows teams to better organize, better maintain, and better scale out their system. You don't need to worry about Drupal path names getting broken because you're breaking up things into smaller pieces and distributing them as needed. You do that through publishing to NPM, which again is not the typical way, the typical Drupal way, but coming up with a way to actually automate that last step of you've published it to NPM. Now how do you pull it into Drupal and make everybody's lives a heck of a lot easier? We kill two birds with one stone here by publishing out the pieces, versioning out the pieces independently. So Drupal developers are happy because they only pull in what they actually want to pull in at what version. And then mapping out which components have been installed and are enabled, teaching that to really the core systems in Drupal allows the design system's codebase to evolve over time while still reducing friction and pain points from your system evolving. And for anyone who's interested, like I mentioned earlier, the Bolt design system is completely open source. It's a product. Definitely check out Margot Romanowski's talk yesterday on really the nuts and bolts workflow process, the people behind your design system, how to actually orchestrate all of it. But Bolt's a product in the sense of It's a design system that's separate from the consumption internally. It's an open source project. Check it out on GitHub. And finally, if you want to learn more, go to bolddesignsystem.com. Funny enough, we now have a Twig Slack channel. I didn't create that, someone else did at DrupalCon. We also have that if you guys have any questions. And thanks. Any questions?
So I've run into some stuff recently where the monorepo approach has made sense for some projects that I've been working on.
Mm-hmm.
So stuff that you did with that tool learn on is particularly interesting. One question I have that you may or may not be able to answer, does it play nice if you're not publishing the packages somewhere, like if you're not publishing to NPM? Is it still a useful tool?
How are you distributing this? So Lerna can help like orchestrate, the button component's gotten a new update, so now anything that uses the button internally, change the version, getting reference. It still has a lot of small utilities and helpers that still make it a really compelling tool. But I would say the most valuable part of Lerna really is that publishing step, where you put all your code base in one spot, and then each piece gets separately published out to NPM so that other people can pull it in.
Gotcha. So it sounds like it still might help with like managing versions, but probably missing out on some of the.
I'd say you're missing out a little bit if you're not using the full Lerna publish piece, but it can still add some value.
Cool. Thanks.
Any more questions? No? All right. Well, thank you guys very much. Again, let me know on Twitter if you guys have any additional questions.